Hi everyone, this is M. Krishna Sai. My registration number is WRK18CS238. In this section, we are going to discuss about the experiment 8, that is implementation of deadlock avoidance algorithm. That means the Banker's algorithm. It is also called Banker's algorithm. In this experiment, we are going to discuss how to stimulate the Banker's algorithm for the purposes of the deadlock avoidance by using the C or C++ or Python programs. In Banker's algorithm, we are going to prove the allocation and the max and the need, and here you can see the algorithm for this Banker's algorithm. You are going to get the values from the resources and the processes, and have to get the available value, and we are going to find after the are going to find the need value after the allocation. We are going to check whether it is possible to allocate or not. If it is possible, then the system will be a safe state, otherwise it will not be a state state. We are going to prove that, and we are going to give a new request to the system whether to check the system is safe or not, and if it is allowed, you can make the request. If it is not allowed, you cannot make the request. In this data structure, we are going to discuss about the allocation and the max and the need and availability. And here you can see that in availability, we are going to initialize vector of the length m, and initializing the each resource type in the system. And here here I I I created if available j is equals to, and here j is the resources, and rj is available, and in max in into max matrix, and here I am initializing max I comma j is equals to k. Here pi makes the request at the k instance of the resources type ri, and in allocation I am initializing as allocation ij is equals to k, and p is currently allocated to k. And in need, if need, and here I initialize need ij is equals to k, and p may be k or more instance of ri to complete this task. Here this safety algorithm, how it works, let work and finish the vectors of m and I respectively. I am going to finish, and we are going to see the example for the Banker's algorithm. Here I created 5 processes from P1 to P5 and the 3 resource system, that is A and B and C. For A resources I given 10 instance, for B I given 5 instance, for C 7 instance. Here you can see how the allocation takes place. This is the resource allocation state at the time 0, and allocation table and max table, and how many available in that. And down you can see the need values how allocated, and we are going to check the whether the system is safe or not by giving the allocation number. And in this example, the allocation is taken P1, P3, P0, P2, P4, and here you can see the sample input and how we're going to give the allocations and the maximums, and the output will be the like this, in this form of the table, the allocation, max and need and the processes. And this is the program I have created, and you can see in this, and here I included the header files, and here I have allocated all the int n comma initialized all the variables n comma n allocation 10, and have given the size for 10 for max also availability and the needs. And you are going to enter the processes, and here all the details I have given. I already told that here availability is checked for the k cases, and we are going to see here the need cases is implemented, and here you can see the max table and the allocation table and need table, and if it is safe it will be allocated, if it is not safe it will be come out of the loop. And you can see the output now. Let's processing. Yeah, we are going to enter the number of processes as 5, and we are going to enter the number of resources as 3, and we are going to enter the number of allocation values for the process 0 is 0, enter, value for process is 0, and we're going to see that enter the details for the process 1 and enter the allocation value for going to enter the allocation value for process 1. I have already finished the for process 0, and I am going to enter 2 0 0 3 2 2 3 0 2 9 0 2 2 1 1 2 2 2 0 0 2 4 3 3 and 3 3 2. You can see that available resources 10 and see here table the processes and the allocations in the max and the needs, and following in a sequential order P1 P3 P4 P0 P2, and where the system is in safe mode and we have implemented successfully the 8th experiment, that is Banker's algorithm. Thank you.